as we finish up this unit that we're talking about number theory, where we're going to end with is with a little discussion of arithmetic and geometric sequences. And so this probably is something you haven't seen a whole lot of. So I want to just start from the beginning and define all our terms. A sequence of numbers is a list in which each number is related to the previous by some sort of rule. Okay, and that's rules defined. And we're going to talk about two different types of sequences with two different types of rules. Within the sequence, each number is called a term. That's how we refer to them. For instance, what we have here is what's called the Fibonacci sequence. It's very famous in mathematics. And in the Fibonacci sequence, each next term, the rule is you add the two previous. So for instance, the first term is defined to be 1. The second term is defined to be 1. And so the third term is found by saying 1 plus 1 is 2. The fourth term is found by saying 1 plus 2 is 3. The next term, 2 plus 3 is 5, etc. And so what would the next term on my list be? Well, the next term would be 55 plus 89. And when you pop that into your calculator, you get 144 would be the next term on the list. All right, so I have my computer here that is doing a little something on me. So 144, and you can keep going on and on the sequence. So just to let you know a little bit about terminology, the first term, which is notated A with a little subscript of 1, A subscript 1 is equal to 1. The second term, notated A subscript 2, that's 1. The third term, A subscript 3, is 2. The fourth term, A subscript 4, is 3, and so forth. I could keep going on and on, but my point's not to bore you here. My point is just to introduce you to the notation and the terminology of sequences. Okay, so with that said, there are two types of sequences we are going to talk about in this class. Okay, the first type is what's called an arithmetic sequence. An arithmetic sequence is one in which each term differs from the preceding one by a constant amount. That amount is called the common difference. So in an arithmetic sequence, the difference between terms is the same for every one, and it never changes. That's what it means to be constant. So for instance, to put some numbers to this so you can see what's actually going on, what we're going to do is we're going to write the first 6 terms of the arithmetic sequence with the first term of 7. So A subscript 1 is 7, and a common difference of 4. And now when you're doing this, you'll note this in the next problem. The common difference, the letter used for that is the letter D. Okay, so here we go. So the first term of the sequence is going to be 7. And then what we do with that common difference is we say, okay, that is the difference between this term and the next one. So 7 plus 4 is going to be 11. That's the second term. And then when I add 4 more, that's going to be 15. When you add 4 more, what is that going to give you? Hopefully you said to yourself 19. We add 4 more, that's 23. That's the 5th term. I add 4 more, that's 27. That's the 6th term. And that's all I asked for, but you don't have to stop there. If you're having a good time, you can say the next term's 31, the next term's 35, etc. Okay, so that's what a sequence looks like. That's how the common difference functions. So I would like you to take a moment, pause the video, and do exercise 1, where I've changed the parameters. I want you to list the first 6 terms of this arithmetic sequence with a first term of 14 and a common difference of -3. Go ahead and pause the video now. Okay, we're back. And so just like the problem I did, the first term is 14, so we will start there. This time, the common difference is -3. All that means is that the terms in the sequence are going to decrease rather than increase. So the term 2 is going to be 14 plus -3 or 11. The next one is going to be 11 plus -3 or 8. That's the third term. Fourth term is going to be 8 plus -3 or 5. The fifth term is going to be 5 plus -3 or 2. And then the sixth term is going to be 2 plus -3 or -1. And 6 terms was all I asked for, so we will stop the listing right there. So in general, if I don't want to make a list, okay, if I just want to focus on one particular term, then there is a shortcut for us. If we want to just find the nth term in an arithmetic sequence, then you find it this way. A subscript n, that's the nth term, is equal to the first term plus n minus 1, so 1 less than the term you're finding, times the common difference. Okay, so this is something you do have to remember. It will not be given to you when you are taking your test. And so how do we know this? This is just a little bit of inductive reasoning. We've used this before in this class. We're just going to follow the pattern. So for instance, as I go down the list, my first term would just be a subscript 1. My second term is found by taking a subscript 1 and adding the common difference to it. So a1 plus d. The third term is found by taking the second term, a1 plus d, and adding another d. So that's a1 plus, when I add another d, d plus another one is 2 of them. The fourth term is found by taking the third term, a1 plus 2d, and adding another d. So that's a1 plus, when I add another common difference, another d right here is 2 plus 1 is 3. I'm going to do one more just so that we can really super clearly see the pattern. So then the fifth term is I'm going to take the fourth term, so a1 plus 3d, and I'm going to add another d, and that is 4d. And we could keep going on, but notice the pattern that results. Okay, the first term is a1. The second term has the a1 and then 1d. Now notice the number of the common difference, the coefficient, is always 1 less than the term. This is term 2, there's 1 in front of the d. Here's term 3, there's 2 in front of the d. Here's term 4, there's 3. Term 5, there's 4. And that is where this comes from. This is just a generalized statement. My nth term is the first one plus n minus 1, 1 less than the term that I'm finding, times the common difference. All right, so I know that that is new and different. So what we're going to do is we're going to flip the page, and we are going to go ahead and use this to find a particular term. So here's my example at the top of the page right there, if I can find it. So example 2 says we're going to find the 8th term of the arithmetic sequence. I should probably spell that right. There needs to be an H there. Sorry. Find the 8th term of the arithmetic sequence whose first term is 4 and the common difference is -7. Okay, so just using this as an opportunity to recollect the formula that we just had on the previous page that we found by inductive reasoning. The nth term, a subscript n, is equal to the first term, a subscript 1, plus 1 less than the term number I want to find, times the common difference d. And now it's just a plug and chug problem. The 8th term, a to the 8, is equal to the first term, which is 4, we are told, plus n minus 1. This first time, I'm just going to write this out. 8 minus 1 times the common difference, which is -7. And then from here, I'm just going to work this out. It's just an order of operations problem. I've got 4 plus parentheses. 8 minus 1 is 7 times -7. The next thing I'll do is multiplication. So that's 4 plus 7 times -7 is -49. And 4 plus -49 is -45. If I was to make a list, the 8th term would be -45. All right, so I would like you now, please pause the video. And exercise 2 is pretty much the same thing. Find the 9th term of the arithmetic sequence described for you there. Hopefully you took the opportunity to pause the video. Remember, learning is doing. And so this was your opportunity to do and to actually engage the material, possibly make a mistake. Mistakes are opportunities to learn. So if you haven't paused it, pause it and do it. So we're finding the ninth term this time of the arithmetic sequence whose first term is 6 and the common difference is -5. Okay, great. Let's do that. So again, the formula from the previous page is the nth term, a subscript n, is equal to the first term, a subscript 1, plus n minus 1, 1 less than the term that we're finding, times d. So this problem asks us for the ninth term, so a subscript 9. The first term is 6. We're told that in the problem. In the parentheses, 9 minus 1. I'm going to not write all this out. I think this is something we can do in our head. 9 minus 1 is 8. And then d is -5, that common difference. So again, just a little bit of order of operations. 8 times -5 is -40, and 6 plus -40 is -34. That would be the ninth term if I went through the effort of listing everything out. All right, exercise 3. Same thing, pause the video, take a moment, and perform that exercise. All right, now that we're back, this time we're finding the 12th term. So a with a subscript 12 this time is equal to a with a subscript 1 plus 12 minus 1 times d. Okay, so this time I remembered the formula and I did one substitution there. So we're finding the 12th term of the arithmetic sequence whose first term is 9 and the common difference is 7. Okay, so the 12th term, first term is 9, 12 minus 1 is 11, and the common difference is 7. So we'll put a 7 there. So that is 9 plus 11 times 7 is 77, and that is 86. So again, if I took the time to make a list, I would end up at 86. So that's arithmetic sequences when you are simply adding the same thing to get each successive term. The other type of sequences, now there's many in mathematics types of sequences. We are talking about these two. These are kind of what I would consider the most basic categories of sequences. That doesn't mean that they're easy or that this is a cakewalk. I know that this is difficult stuff, but there's the discussion of sequences in math goes on and on. These are called geometric sequences. A geometric sequence is one in which each term is found by multiplying. Okay, so this time it's not adding, it's multiplying the previous term by a non-zero constant. I guess I got constant twice there. So non-zero constant, we'll cross that one out. This constant is called the common ratio. Okay, great. So example 3, this is going to be my example. We're just going to do what we did previously for the arithmetic sequences. We're going to find the first 6 terms of the geometric sequence this time with the first term is 6 and a common ratio of 2. Okay, so if the first term is 6, now this time what I do with my common ratio is I multiply the previous term. So 6 times 2 gives me a second term of 12. And then times 2 again gives me a third term of 24. Times 2 again gives me a fourth term of 48. Times 2 again gives me a fifth term of 96. And then times 2 again gives me a common term. Let's see, 90 and 90 is 180 and 12 is 192. And we can keep going, but that's just what I wanted us to do in order to get the picture of what's going on. So right below that, exercise 4 is one for you. I want you to find the first 6 terms of the geometric sequence with a first term of 12, and the common ratio is a half. Okay, so now instead of multiplying each one by 2, you're multiplying each one by a half. All right, so hopefully you took time to pause the video. So here we go. 12 is the first term. And if you need your calculator, if you need your scratch work, that's fine. Remember, multiplying by a half is the same thing as dividing by 2. Those are equivalent operations, whatever is easier for you to think about. So 12 times a half is going to be 6. That's the second term. 6 times a half is going to be 3. That's the third term. 3 times a half is going to be 3 halves, or maybe used a decimal, 1.5. Decimals would be acceptable in this one because they're going to terminate. 3 halves times a half is going to give me 3 over 4, or 0.75 if you're using decimals. And then 3 over 4 times a half is going to be 3 over 8, or 0.375. Let me confirm that. It's a little early when I'm recording this, and I never trust my early morning self. 0.375, yes. And again, we could keep going, but that is enough to get the idea. All right, one more of these, and then we're going to flip the page and finish this section out. So exercise 5 asks you to do the same thing. 6 terms of the geometric sequence that starts with 20 and has a common ratio of -2 over 5. All right, so this is also good practice for recalling our fractions and how to work with them. So the first term is 20. So there we go. The second term is going to be 20 times -2 over 5. Now, this is not quite as easy as a half. So I'm going to do a little scratch work here. So 20 is 20 over 1 times -2 over 5. So 20 times -2 is -40 over 5, and -40 over 5 is -8 as my second term. Then I'm going to take -8 and I'm going to do the same thing. So I've got -8 over 1 times -2 over 5. So -8 times -2 is +16. 1 times 5 is 5. So I'm going to leave it like that, 16 over 5. If you went ahead and made that a decimal, I believe that's going to be 3.2. So that's what you've got. Now we're going to take 16 over 5 times -2 over 5 to get the fourth term. 16 times -2 is -32. 5 times 5 is 25. That does not reduce at all, so -32 over 25. If you made that a decimal, which I'm not going to, but 32 divided by 25 is 1.28 is what you're looking at. That's my fourth term. The fifth term is going to be -32 over 25 times -2 over 5. So a -32 times -2 is +64. 25 times 5 is 125. So that is my fifth term. And again, if you made that into a decimal, 64 divided by 125 is equal to 0.512. And just to reiterate, that is, decimals are acceptable on this because they are terminating decimals. If they were repeating decimals, I would want to see the fractions. We always want to keep our answers exact and precise. Last but not least, 64 over 125 times -2 over 5. Well, 64 times -2 is -128. And then in the denominator, 125 times 5 is 625. That pen inconveniently decided to run out of ink. Sorry about that. Now I've got a different green. And so that is going to be -128 over 625. And so again, going to the calculator, if you did decimals, 128 divided by 625 is going to be 0.2048. And so that is the next 6 terms of that geometric sequence. All right, one more thing. We're going to end this discussion of geometric sequences the same way we did with our arithmetic ones. If we want to find the nth term of a geometric sequence, it's given by this formula. Again, you need to remember this, that the nth term, a subscript n, is equal to the first term, a subscript 1, times the common ratio to the power of 1 less than the term number. So there's a similar kind of structure to this. And again, how do we know this? Well, again, let's just do our inductive reasoning approach. The first term is a with a 1 subscript 1. And then how do we get each successive term in a geometric sequence? We multiply by the common ratio. So the second term is going to be a1 times r. Now the third term, I'm going to multiply the second term by r. So I've got a1 times, when I multiply this by r times another r is r squared. The fourth term, we're going to multiply the third term by the common ratio. So that's a subscript 1. And when I multiply r squared times another r, that gives me r to the third. I'm going to do one more, but as we're writing this down, you can see the pattern develop just like we did with arithmetic sequences. Okay, every time I'm multiplying by another r, you can see the power on the r is lagging one behind the term that we are talking about. So the fifth term is I'm going to multiply the fourth by r. So that is a subscript 1. And when I multiply r to the third by r, that is r to the fourth. So that is where, by induction, we get this, that each successive term is a1. Okay, so we see the a1s times r to 1 less power. So the fifth term is r to the fourth, the fourth term r to the third term r to the second term r to the first term there's no r there at all. So let's go ahead and use this, and then we will be done with our brief overview of geometric sequences. So we're going to find the eighth term of the geometric sequence whose first term is 4 and has a common ratio of 2. Okay, great. So the formula is a subscript n is equal to a subscript 1 times r to the n minus 1 power. So in this case, we're finding the eighth term. So that is a subscript 8 is equal to the first term, which is 4, times r, the common ratio, which is 2. And since we're finding the eighth term, that's going to be 8 minus 1, which is going to be 7. So this is 4 times 2 to the 7th. At this point, I'm going to grab my good buddy, the calculator, and we're going to first do 2 raised to the 7th power, and that is going to be 128 times 4. That equals 512. That would be the term that we get. That would be the eighth term. All right, so the one you're going to do here, you've got kind of a when you use geometric sequences in the area of finance, which is a big application of this, you see a lot of decimals. So I made the next 2 problems with decimals. So I would just like you, when you do these problems, each of these, because you're going to have to round to the 100th. All right, so go ahead and find the 9th term of the geometric sequence with a first term of 5 and a common ratio of 1.5. Pause the video and go ahead and do that, please. Okay, so let's see how you did. So the formula for doing this is my nth term, a subscript n, is going to be equal to the first term, a subscript 1, times r to the n minus 1 power. So in this case, we're finding the 9th term. So a to the a 9th is equal to the first term, which is 5, times my common ratio, which is 1.5, and the power is going to be n minus 1. So 9 minus 1 is 8. So this just becomes a calculator problem. So I've got my 1.5 that I'm going to raise to the 8th power. And when we do that, we get 25.6289065. Don't round yet. Multiply that by 5. And I get 128 point, and I asked you to round to the 100th, so 1.4. That is the approximate value of that term. Last one, exercise 7, same thing. Find the 12th term of that geometric sequence right there, please. All right, here's our final one. So when I go to do this, my formula is the nth term is equal to the first term times the common ratio to the n minus 1 power. Okay, so that is going to be, in this case, the 12th term is equal to my first term, which I made 145,000. The common ratio on this one is negative 1.05, and we're raising it to the 12 minus 1, or the 11th power. So once you've got that down pat, now you just go to your calculator, which I have right here, which you can't really see the screen for some reason. Let's see if I can adjust this light. Okay, that's a little bit better. Okay, so here we go. I've got negative 1.05. Don't forget that negative that we are raising to the 11th power. Ooh, I need to put that in parentheses, so let's try again. And what we end up with here is negative 1.71033 on down the line. Remember, I asked you to round to the 100th. Let's not round until we've multiplied times 145,000. And that is one too many zeros. So where's my delete button? There we go. There we go, 145,000. And so we get negative 247,999. So 247,999.21. So that is going to be a value of negative 247,999.21. That is the approximate 12th term. I hope you've enjoyed this introduction to arithmetic and geometric sequences. That's going to conclude this class's brief survey of the topic of number theory.